sum of exterior angles of a polygon. So for that, I want to draw, first of all, I have to draw a triangle. So I'll draw a random triangle like this. So when we extend each side, okay, I'm going to extend this side, I'm going to extend this side, I'm going to extend this side as well. So we know how to denote the interior angles. Interior angle means those are located inside. So its corresponding exterior angle would be not this one. Okay, this is not our exterior angle. When you extend this line, one angle was already occupied, no? So the remaining adjacent angle which corresponds to the interior angle, this is called as our exterior angle. So here also we just extended this line. If this is our interior angle, its corresponding adjacent angle would be our exterior angle. Here also, when we extend this line, not this one, not entire 180, okay? If this is interior angle, its corresponding adjacent angle would be our exterior angle. So, sum of exterior angles in a triangle that is equals to 360. In our grade 8, we did some practicals. We just cut all these angles and pasted over a line and pasted surrounded by a point. Okay. Likewise, we did some experiments. From that, the conclusion was sum of exterior angles of a triangle would be equals to 360. Sum of exterior angles of triangle equals to 360. How to identify the exterior angle? That is also important. Not the entire angle is not exterior one. You should extend a line of this triangle and with correspond to the interior angle only we can understand which one would be the suitable exterior for this particular angle. Likewise, we just found 1, 2, 3. Sum of all these should be equals to 360. Likewise, now we are going to think about quadrilateral. Okay, first I'll draw a random quadrilateral. Okay, I'll draw like this. Okay. I'm going to extend all these sides. Okay, I'm going to extend this side here, extend this side here, extend this side here, extend this both side here. Okay, what are the interior angles? This is the interior angle. So corresponding to this one, the extended line, we can identify the exterior angle. I will show you. Its exterior angle would be this one. This one's exterior angle would be this. Its exterior angle would be this, not this one. Straight line means that is 180, no, not that one. With the corresponded to the interior angle, the remaining would be our exterior one. Likewise, here also, this is our exterior angle. I'll use capital E letter. In a quadrilateral also, we did the experiment in grade 8 under the subject called triangles and quadrilaterals. Sum of exterior angles of a quadrilateral also equals to 360. 360. Sum of exterior angles of a quadrilateral. It would be equals to 360 as well. We are going to get the summation. Okay, here I used E letter to denote the angles. Actually, they will have some numerical values. No, when we add those values, that will give you 360. So now the experiment is we are going to draw an octagon. Octagon means that should have totally 8 sides. 1, 2, 3, 4. Just look at this how I am drawing. 5, 6, 6, 7, 8. This is an octagon. So what we are going to do is just we are going to extend each sides. 1, 2, 3, 4, 5, 6, 7 and 8. So your task is do the task individually. Measure this angle, this exterior angles, measure all these exterior angles carefully and get the summation of them. First do the task by yourself, then I'll explain how to measure each angle. You should place your protractor. For in this case I'll guide you. So here make this one, just consider this one as a base and place exact origin of your protractor here. Okay, protractor's origin should be aligned here and measure how much this is deviated from 0. For an example, this is 42 degrees. But to measure the second angle, you should place your protractor like this. The origin should be aligned at here. Then measure this angle. This is 48. Likewise, to measure here, the protractor should be little bit inclined, but exactly the origin should be here. How much this angle is deviated, this line is deviated from 0. That's what you have to measure. So if you measure all these angles individually, there are several angles, but when we get the summation of all the exterior angles, sum of exterior angles in this octagon, it is also equals to 360 degrees. Previously we found for triangle, what is the exterior angle sum? 360. For a quadrilateral, that also 360. Thereafter we found for octagon. For the octagon also, it is also 360. From here, we can get a conclusion that sum of exterior angles of all the polygons, doesn't matter how many sides it has. It can be 3 sides, 4 sides, 5 sides, 8 sides, 10 sides, 12 sides. It doesn't matter. But if it is a polygon, if it is consist of only, it is created by using only straight line, that is called as a polygon. In that polygon, sum of all the exterior angle would be exactly equals to 360. Don't forget it. Sum of exterior angles of a polygon always 360. But interior angles, that is different. For triangle, sum of interior angles 180. For quadrilateral, 360. For pentagon, 540. For that one, to find any polygon's interior angle, we can use n minus 2 into 180. Okay, 180. When we use this formula, we can find the interior angles, sum of interior angles of a polygon. But there is no any equation to find the exterior angles of a polygon. Always for all polygons, sum of all the exterior angles exactly equals to 360. It is simple, no formula. But for the interior angle only, you have to be careful. You should use this proper formula to find the answers for different cases. So here there is a quadrilateral because it has 4 sides now. So sum of these exterior angles were denoted. We need to find the magnitude of x. Doesn't matter any polygon. Sum of exterior angles always 360. So x plus this is a right angle. This is also a right angle. You have to check whether that is an exterior angle or not. So while when you extend this line, this would be our exterior angle. Correct. Extending here, we got this exterior angle. Extending here, we got our exterior angle. And when you extend this line here, this is the exterior angle. Okay. Corresponding to the interior angle, remaining adjacent angle would be our exterior one. So all these given values are exterior angles. So that is the first thing you should do. Then get the sum. X plus 90 plus 90 plus 130, that is equals to 360. 90 plus 90, 180. 180 plus 130, 310. X plus 310, that's equals to 360. From that, we can find the answer for x as 360 minus 310. That will give you x as 50 degrees. Simple. How I found? First of all, I identified whether these are exterior angles or not. That is the important thing. This is the interior angle. So correspondingly, when you extend this one, we found our exterior angle. Here also, this is the interior angle. When you draw a straight line, this would be the exterior. Here this is the interior, correspondingly we extended to find the adjacent exterior angle. Here also this is our interior angle when we extend this line. Okay, it doesn't matter when you extend in this way or in this way, but you should identify the proper exterior angle. Here the exterior angle is 130. Finally, after simplification, we got the answer for x as 50 degrees. In this case, a and b, there are two variables. To find the a, look at this. There is no any theorems, okay? No any polygons interfered here. You can easily find this. This is a straight line. In the straight line, sum of adjacent angles would be equals to 180. By using that, from 180, when we subtract 115 degrees, that will give you a as 65 degrees. Magnitude of a would be here 65. Yeah. Thereafter, sum of exterior angles of a polygon equals to 360. B here 65. This is not an exterior angle, no, this is interior angle. If the interior angle is 90, its corresponding exterior angle also would be 90. Carefully look at this. This is exterior angle, but this 90 is not exterior one. This is interior. By using that, you should find the exterior angle. That also would be 90. Now, I'll write an expression. B plus B plus 65, B plus B plus 65 plus here 90 exterior angle, here also another 90. 90 plus 90. This should be equals to 360 degrees. BB 2B 90 90 180 plus 65, that would be 245. That's equals to 360. Thereafter 2B would be 360 minus 245, that will give you 115. Then B is 115 divided by 2. That will give you 57.5 degrees. That is the magnitude of B. A directly you can find using straight lines, adjacent angles. You can find the summation, that is 180. So A plus 115 equals to 180. From 180 we can easily subtract 115 to get the A as 65. Thereafter try to identify all exterior angle. Thereafter plug them into a formula. Equalize it to 360. B would be 57.5 degrees here. Because in this case, look at this. This is a triangle. No? In the triangle, even though this question is not about to find the interior angles of triangle, we are just talking about the polygons exterior angle. You should apply whatever the theory you know earlier. Okay, in some cases, this question combines overall comprehensive knowledge. So you should have the knowledge as well. So here, sum of interior angles of a triangle equals to 180. No? So here 2x plus 40 equals to 180. 180. This is a theorem from grade 8 and previous grades. So 2x is 140. X would be equals to 140 divided by 2, 70. Okay, now we got the answer for x. Thereafter, you should find the magnitude for y. For that one, somehow we need to use the exterior angles of a polygon. Here we know one exterior angle, this is y, plus here this is interior angle. No, corresponding exterior angle would be also 90. 90. Another exterior angle, here we have 70. In this case, only look at the pentagonal shape. Okay, only look at the pentagonal shape. Here, its exterior angle would be x. Okay, its exterior angle would be x. That means another 70. X is 70 now we found. Again, look at here. When you extend this one, we will have, this is our interior angle. Its corresponding exterior angle would be this one. What is this one? To find the magnitude of y, here we have X shape, capital X shape. We know that when you have capital X shape like this, these are vertically opposite angles. So if this is X, This also, the exterior angle also would be x. X means that is also equals to 70. I'll repeat once more. Y here 90, 70, here x, so 70. Here to find this is the interior angles, corresponding exterior angle would be, when you extend this line, this is the corresponding exterior angle. To find the magnitude, there is no any direct relationship. You can use vertically opposite angle theorem to find this one also as x. We know the magnitude of x as 70, that's what I have substituted. So sum of all the exterior angles of this polygon equals to 360. 90 plus 70 plus 70, that is equals to 300. 300. 360 equals to y plus 300. From that you can find the magnitude as 60 degrees. Don't think that the theorems which we've discussed in earlier class are not relevant for here. Somehow all the knowledge, the comprehensive knowledge is important to deal with these kind of theoretical questions. Here only the concept we discussed is exterior angle sum of a polygon, but somehow you should use vertically opposite angles and interior angles of a triangle theorems also. Yeah. The data says there are 5 angles in a pentagon. No, pentagon means it should have 5 angles. The ratio between all those angles in a pentagon, ratio between the angles, exterior angles of a pentagon, that is given as 1, 1, 2, 3, 3. The data says the exterior angles of a pentagon are in the ratio of 1, 1, 2, 3, 3. Find the magnitude of each of these exterior angles. So this is about exterior angles, pentagons, exterior angles. This is the ratio. So only we have ratio. We didn't have any other data than that. So you have to convert, you have to extract some relevant details from the given ratio. So if you have ratio, you should multiply that one with a constant by using a constant. For an example, I will multiply everything by k. So this angle would be 1k, this angle 1k. I used a random variable here, 3k. This is also 3k. These are ratios. We don't know this is 1 degree or 10 degree, 10, 10, 20, 30, 30. It's possible. 100, 100, 200, 300, 300 possible. So we don't know the constant. So that's why I used a random constant. So when we get the summation of all these angles, these are pentagons exterior angles. No, sum of all these angles must be equals to 360. We know that rule. No, so that's what we need to apply here. 1k plus 1k it's 2k, 2k plus 2k 4k, 4k plus 3k it's 7k plus 3k 10k. Okay, 10k. Just I used the ratio which is multiplied with a random constant to make it as a suitable value. 10k equals to 360. 360 degrees. So k is 360 divided by 10. That will give you k as 36 degrees. By our own, we introduced k here. No, there is no any k in the given question. So we introduced k. So to nullify that, one portion means, okay, 1k denoting 36 degrees. So 1 times of 36 would be 36. The first ratio value, this portion of 1, exactly denoting 36 degrees. Here also, next angle also denoting 36 degrees. Thereafter, we have two portions. 2 times of k. 2 times of 32, it would be 72 degrees. And 3 times of 36, that is 108 degrees. And the last angle also exactly 108 degrees. What I did first, pentagons exterior angles ratio given. I used a random variable to multiply to make them as a common values. Thereafter, when we add all these, we know that that is definitely equals to 360. From that, I found the value for the random variable k, which is 36. So 1 times of 36, 36. 1 time of 36, 36. Likewise, we found all the exterior angles for that particular pentagon. If you have some ratios, this is the way you should follow. Not only k, okay? You can use whatever the variable you want. That's your wish. There is no any restrictions for that one. So here the quadrilateral means all the angles. So let's get the summation. X plus 2x plus 3x plus 4x means when you get the summation, that is equals to 10x equals to 360 degrees. X should be equals to, that means 360 divided by 10, 36. So all the exterior angles, so x degrees means first exterior angle would be 336. 2 times of 36 it would be 72. Then 108, thereafter 144. These are the angles, and they are interior angles also. Another question is interior angle. For an example, I will draw a quadrilateral and explain. Look at this. This is a random one. Here, this is 36. This is 72. This is 108. This is 144. Example. So that means their interior angle. How to find its corresponding interior angle? From 180, when you subtract the exterior angle, you can find the interior angle. No. These are oriented in a straight line. So these are adjacent angles. So 180 minus 36, that will give you its corresponding interior angle would be 144. And its corresponding interior angle would be, if this is 72, its interior angle, sum of both of them would be 180. From 180, when you subtract this 72, it is 108. Likewise, for 108 degrees, its corresponding interior angle would be 72, and for 144, the corresponding interior angle would be 36. So these are the correct answers for the question.